right, so type 2 projectile motion. We did type 1 yesterday. Type 2 are objects that start on the ground, get launched into the air, and land back on the ground. So, kicking a soccer ball, hitting a golf ball, a baseball, throwing a football, throwing a baseball, basketball, anything pretty much where there's an object that starts on or near the ground and then gets thrown up into the air and lands and is caught, lands, does whatever again. Okay, so those are type 2 projectiles. Start on the ground, end on the ground, or close to it. So the specific information about type 2. The first thing you have to do is determine the x and y components of the velocity. And so we talked about component vectors earlier in the chapter. Same thing. Right? When that ball gets kicked, launched, thrown, hit, whatever, at that angle, it's got an x component and a y component of that velocity. So we need to find those using the x component, Vx, vi cosine of the angle, and the y component, the initial y velocity, vi sine theta. So just back to using component vectors. Second, to find the total time in the air, right, how long it takes for the ball to land or rock or whatever to land, you're going to set dy back equal to 0. Right, just like we did when we were talking about throwing the ball up in the air when it lands, finding the total time in the air, same exact thing, because in the y direction, it's in free fall. So when it comes back to the ground, it's got a displacement of 0 again. And finally, to find the range, right? We talked about range, how far it goes in the x direction. I'm going to use that total time in the air along with dx equals vxt, right? The velocity component in the x direction multiplied by the time it's in the air. It's going to give me the range or distance in the x direction. Finally, last thing, to find the maximum height, right? So the ball goes up in the air, there's a height at which it reaches a maximum. What happens at the top? In the y direction, that y velocity becomes 0 as it's going up. It's having a negative acceleration due to gravity, so it gets to 0 at the top and then starts to come back down. So again, we're going to set that final velocity at the top to 0. Now, a couple people made the mistake in the test, I believe it was, where you used the total time in the air to try and find the maximum height. The total time is not at the maximum height. The total time is when it's back on the ground. So the time you find is not going to be the time you can use to find the maximum height. What will be the time to the maximum height? Let's suppose the ball gets thrown and it's in the air for 2 seconds. How long will it take to get to the maximum height? Somebody be brave and suggest an answer. If it takes 2 seconds to get thrown up in the air and come back to the ground, how long does it take to get to the maximum height?
Is the second random pass?
No. Think about it.
1
second, right? It's symmetrical. If it's being accelerated by gravity at negative 9.81 meters per second squared on the way up, and it starts at whatever, 3 meters per second, it's going to go up to 0 and then come back down. It's going to reach 3 meters per second on the way down. It's the same amount of time going up as it is going down when it's coming back to the same level. And so you can kind of use that trick if you want, but again, you're using that calculated value. All right, so let's take a look at a type 2 projectile. All right, so we're going to start with a soccer ball. Okay, so appropriate. I got my Philadelphia Union shirt on there, or scarf on there in first place. Let's put some spikes. We'll make it an Adidas shoe. Okay. So, soccer ball is going to be kicked with an initial velocity of 10 meters per second at an angle of 35 degrees. And I'm going to want to know how far the ball travels. No, it's the first question I'm asked for. How long the ball's in the air. So I need to find out the time when it comes back to here. How far the ball travels. So I'm looking for the range. Right, the x displacement, and then I'm going to be looking for the maximum height, dy max. Okay. Typical questions you're going to get asked in a projectile motion problem. So I'm going to start. So there's step 1 in my 5-step physics problem solving system. That beautifully drawn picture. Step 2 is list the variables. Guess what? The variables are the same as they were for the type 1 projectiles. Well, I've got VI. We'll talk about that in a minute. Then I'm going to do my little T-chart here for my X variables and my Y variables. My X variables, Vx, because it's constant, dx, and T. In the Y direction, VIY, the Fy, Ay, which is G, which is negative 9.81 meters per second squared, dy, which is the height of the object, and T. So again, same variables we've been using, still there again. So I can fill in some of these. I was given that the initial velocity, what was it, 10 meters per second at 35 degrees. So going back to my original thing, first thing, determine the x and y components of that velocity. Right? I need to know the Vx and the VIY. We'll do that using the sine and cosine. So Vx is going to be equal to 10 times the cosine of 35 degrees. And VIY is going to be 10 sine 35 degrees. And now I need my calculator. So 10 cosine 35, 8.19. So my x velocity, 8.19 meters per second. My initial y velocity, 10 sine 35, 5.74. meters per second. Okay, so that now completes step 2. Got my variables listed. I got all the variables I know put into the equation. Now I'm ready to start answering the questions that I've been asked. So, A says how long the ball is in the air. So I need this total time. So part A, total time in air. According to my reference here, find the total time, I'm going to set dy equal to 0. Set dy equal to 0. So I'm going to make this dy 0 for part A. And now I need an equation that has time in it that doesn't have final velocity. It's going to be dy equals 1/2 gt squared plus diyt. So that's step 3. I've decided on the equation I'm going to use. Step 4, substitute in my values. I'm set dy equal to 0. 1/2 times negative 9.81 t squared plus 5.74 t. Simplifying my problem here, negative 4.905 t squared plus 5.74 t. Just like we had in the last chapter, that's a quadratic. The simplest way to solve this quadratic is to factor it. Right, so I'm going to pull my t out. Negative 4.905 t plus 5.74. So either t is 0 or this part is 0. T is 0, right? The height is 0 when the time is 0 at the start. That's not the one I want. The height is also 0 when it reaches this time over here. That's this factor, the second factor of the quadratic. So I'm going to make that second factor, set that equal to 0, and solve for t. Subtract the 5.75 or 74. That makes me value in that 5.74, and divide it by the 4.905. 5.74 divided by 4.905. Those are both negative. I'm going to get t equal to 1.17 seconds. Okay, so my part A solution, the ball spends 1.17 seconds in the air and then lands back on the ground. Question B says, how far does the ball travel? So that's looking for the range. So question B is asking for the range. So in the x direction, right, in step 3, I'm going to select my equation. In the x direction, I only have one equation to choose from. dx equals vxt. Now I have to be a little optimistic here, because the only way to find that is to use the time value I calculated in how long the ball was in the air. So if I got that one wrong, I'm going to get a carryover mistake, and I'm pretty confident in that answer. And again, that's why you want to show all your work, so if it is a carryover mistake, it's easy to see. You understood what to do. You just made a calculation error someplace before. So I'm going to say dx equals vx 8.19 times 1.17. So back to the calculator. 1.17 times 8.19 gives me a dx of 9.58 meters. Not a very far kick. Not a very far kick at all. Okay, now, again, be careful because we're going on to part C. Part C wants to know the maximum height. And we're talking about up here, when the ball's up here, not when the ball lands. The time is not 1.17. We could use half of that time if we wanted to, but again, then we'd be using a calculated value. So for part C, the max height, and I'm going back to find the maximum height, set the final velocity equal to 0. So I'm going to set VFY equal to 0 because it stops at the top of its trajectory before it starts coming back down in the Y direction. So then I need an equation where, so for part C, this is 0, and I'm looking for the max height. So for part C, I'm looking for the max height. So I'm going to pick an equation without time in it. That's our trusty dFy squared equals VIY squared plus 2G dy. Again, don't worry about memorizing the formulas. You'll have a sheet that has the formulas on it. I don't expect you to memorize the formulas. So VFY, I'm going to set that to 0 squared equals initial velocity 5.74 squared plus 2 times negative 9.81 times dy. Ooh, 5.75 squared, well, 5 squared is 25, so it should be a little bit bigger than that, but less than 36. So 0 equals 32.95 plus a negative 19.62 dy. Subtract and divide. And I get a maximum height of 1.68 meters. Again, like I said, this was not a very powerful or far kick. It only goes a little over a meter and a half in the air, and it only travels about less than 10 meters, so not a great kick. All right, so there is a type 2 projectile motion problem. Again, it doesn't matter if it's a golf ball, a baseball, a rock, or whatever. Type 2s start on the ground, land on the ground.